All right, so this is just an impromptu session to try out some Clojure. I guess we're both just starting out.
Yep.
So I'm just going to fire this up and go and see what happens. So let's get rid of that.
Ah,
My desktop.
Millennium Falcon is much better than the tunnel.
Yes, way better than the tunnel. Okay, so
Hey, Jonathan.
Hey, what's up?
hey, how's it going? I think I have I don't know if I need to go to a specific folder. So I guess to open up a REPL. So I think, because I have Leiningen installed. I think that's how you pronounce it. Leiningen? Does anyone know? I heard
That's
someone
how I
pronounce
would
it that
pronounce
way.
it.
Okay. I do like, I don't know, has anyone, you've probably seen it because I'm pretty sure you have it installed. I still have to figure out how to spell it. There's an image on the README that's pretty cool. There it is.
Yeah.
All right, so that's I guess that's not really what I'm trying to do here. Okay, so I was talking just briefly. I was playing on foreclosure.com, and one of the problems on there was to rewrite the max function. So, given a list of numbers, return the number that's the largest number. So I've gone through this, like, I solved it last night with a little help from Google, and I keep trying to go through it, and rewrite it just to kind of cement how it's created in my head. So I think I'll probably start with that and hopefully try to explain it as I go along. So I don't know. I think Derek, you said you've played a little with Clojure. Jonathan, I think you've looked at it a little bit, um, but I'm just going to start with some real basics because I'm still learning them myself. I'm still getting used to I think it's called infix notation. I'm not sure if that's the correct term, but like, so if you were adding 1 plus 1, it's like this.
No, that's not infix notation.
Prefix? Something fix.
Maybe. Prefix. If it's a fixed notation, then it'd be prefix.
Okay, prefix. Whatever that is, where you put, basically your code is a list, and the first element of the list is the name of the function. So then, like, if you did it's saying, essentially it's evaluating is 2 greater than 3, and it comes up with false. So if you said, I should say true. Or if two, then work. I don't know if that's going to make any sense. What does that say? That says if 1 is less than 2, then print 1. Otherwise 2. That doesn't make much sense. But that's how you would write that. Let's see if I can come up with something that makes a little more sense. Okay, so talking about max, kind of the core of that whole function is returning the greater of comparing numbers and determining which one's greater. So one way to do that would be just using an example with numbers that we know. Be like that. So if 1 is less than 2, then return 1, otherwise 2.
So that's going to give you the minimum.
that'll give you the min. So then if we want the max, we do that.
Agreed.
So if we want to turn that into a function, we could do... Okay, so let's go to function. I'm just going to use anonymous functions, which I know very little about, but just enough to be dangerous. So the basic idea behind an anonymous function is you define it with fn, and then it takes some parameters, that, and the parameters are passed in as a vector. You can give multiple parameters like that. Just go with one for now. So let's make a function that takes a name and then says hello in the name. So backing up here for a second, just concatenate strings. You use str, so you could say hello space world, that, and you end up with hello world. So then if you wanted to make a function that lets you change what you're saying hello to, you could do something like think this. So we're going to define the function and we're going to pass it some values so it evaluates. So function name. So we've defined that we're making a function and we're going to pass it a I don't know if variable is the right word, parameter called name. And then pass it to this str, and it will say hello name. And then that's the end of our function. And then we want to pass it a value, so we could say that. And then this should print out hello Derek. Yay, I did it right. So if we wanted to create a function that's not anonymous, do this, and then we give it the actual name. We'll call it hello. And actually, I think you can... I don't know how it works with indenting in Clojure. I'm kind of clueless, but we'll just kind of space over here some. And then
I don't think it matters how you do it.
Okay. There's probably some sort of standard. I just don't know what it is yet.
Agreed.
So you're defining a function. You give it the function name, which in the anonymous function you don't give it a name. Then you set up your parameters just like you did before, and then comes the actual body of the function, which will be so. It should create a function called hello in my user space. So user namespace, name of the function is hello, and I should be able to say yep. Okay. So
Were you checking to make sure we were still here?
I was seeing if you're still with me.
Yep.
Okay, cool. So that's hello. So now let's go back to this max. Let's create a function that's going to return greater of two numbers. And we'll call it maybe GT.
Is max a reserved word?
I don't know.
Okay.
No, it is. It is. It's so like if you it already exists. This should give us 4.
Okay.
So we're gonna do something different. This one only takes 2 numbers, and it's going to give us the one that's greater. So we'll call it GT. It takes X and Y. Okay.
Agreed.
And if X is greater than Y, then we want X, otherwise we want Y.
Looks good.
Okay, so let's try it. GT 1, 2. Okay, and GT 2, 1. And GT 2, 2.
All right, guys. I will be right back.
All right, cool. So now comes the tricky part. We want to make this work on a list. And this is where some of the stuff that is available in Python, like map, reduce, filter, that kind of stuff that's I'd heard of before and I'd used a little bit, but didn't really, understand its roots. Seems to be coming from stuff like this. So, like, let's take this, and so we have a function that takes 2 parameters and gives us the greater one. And we're going to now use that to apply this greater than to a full list. We'll call this def and my max. Well, first of all, we're going to accept the parameters using this ampersand notation, which say args. What that does, I'm not sure exactly what it does, but what it allows us to do is to accept. I think what it does is kind of like when you do args in Python. So you do ** args, and it just says, okay, I'm going to grab everything. I think that's what it does. So putting that ampersand here says, okay, everything that gets passed here, shove it into this args as a list. So that basically allows us to accept a list as a parameter.
Okay, because I had to use that ampersand when one of the challenges on exorcism is for the hello world one, the first one, you have to write a program or a function that says hello, whosever name you put in, or if no name is there, then just say hello world.
Mm-hmm.
And to get it to work, I think I used the ampersand thing because, like you said, it's like args in Python, so it was allowed to have no argument be present. So if no argument was present, then the function still works.
So it wouldn't give you an arity error because you were missing a parameter if you didn't pass something in.
Right.
That makes sense. Okay. So now what we want to do is we're going to use, if I remember correctly, we're going to use reduce. And we have our GT. So GT. When I did it, I didn't do it exactly like this. GT. Args? No, we'll try this, see if it works. I used anonymous functions when I did it. Yeah, there we go, that works.
Yeah.
Okay. So what's going on here? Reduce is it's a pretty cool function. What it does is it accepts two arguments. One of them is going to be a list, and one of them is going to be a function. And it's going to take each. I think what it does is it takes the first item off of that list, compares it to either the next item in the list or the rest of the list. I'm not sure which, but it evaluates that function, and then it returns whatever value that function returns, and then it applies it to the next. So basically, it chews through that entire list to reduce that list into whatever this function does. If that makes sense conceptually, I think it's a bit of a leap to understand what it does. I'm not sure I fully understand what it does internally, but basically what you're doing is a reduce will take a list and apply a function across all elements in that list in order to reduce that function down to a single value, or that list down to a single value using that function. So we have this greater than function that accepts two arguments and returns the greater than, the one that's greater. So like if we made a less than function, this, and then my min, and just applied less than across reduce, it should give us the lowest number.
Yep.
So what this reduce is allowing us to do is basically what you would normally do in Python that looks like, here, let me open up a Python session. If I can, what did I do?
Oops.
Oh, account. Dash. Okay. So then if you had the our max val equals 0 for x in my list if x is greater than max val x equals, I don't know, x equals x. Max val. Okay, it's 4. So what reduce is doing is all of that.
That's pretty nifty.
Yeah, it's creating this kind of external, that outside of the scope of the loop value.
Yeah.
It's then applying the function, which is this, across each element of that list, allowing it to update this kind of external value, and then it'll return this reduced value. There might be something in Python. There probably, wrong window. There's probably a Python version of reduce. Let's take a look. Let's see if we can try it out to lambda. Hey, it's the lambda from the Clojure symbol. Reduce. So reduce accepts a function and a list, just like it does in Clojure. So let's try Python reduce. So we have my list.
Hey guys, I'm back.
Hey, I'm just trying to do a reduce in Python for a comparison, because we used reduce over here to apply this greater than function across all the elements of a list. And so you can see
Nice.
here, it was actually, here it is. So we created my max, and all it is you use this ampersand here so that it's kind of like star args in Python, where it just accepts all of the arguments into a single argument or parameter.
Okay.
And then call reduce with a function and the list, and it just chews through it and gives you your result.
Nice.
So we're just trying to do that in Python just to get a better grasp on what exactly it's doing.
Okay. Hey Clifton, welcome to the Hangout.
Hello.
Hey, Clifton.
Am I on?
Yeah, you're on.
There you are. Yep, there you are. I'm going to drop that because I don't like the tunnel of doom. We're just going through we're doing a little comparison of Python and Clojure syntax of creating a function that will return the maximum value from a list.
Oh, nice.
So, and why is there common? Probably common Python. I think we're going to have to create a function for this. Def greater than xy. If x is greater than y, return x, otherwise return y. My list. Okay, we got a list, so let's give this a shot. Use greater than my list. Oh, I need a comma.
So this is just pure Python?
This is Python here, yeah.
Okay.
This is Clojure over here.
Okay.
Okay, so that works. So it's the same idea. In Clojure, you have reduce, you have your function name, and you have the list that it applies it to. And in Python, it's a little different syntax, but it's reduce, the function, and the list that you're applying it to.
Yeah, I believe Guido got reduce from the functional programmers who
That makes
wanted
sense.
it added to Python.
That makes sense. All right. So let's give Foreclosure a try. I'm going to sign out of mine so we can start it like a. Oh, I'm not in mine right now. Okay, good. So we can start with like the intro stuff. I don't know, Clifton, if you've seen Foreclosure, it's pretty cool. It's a site, so.
Yeah, this is like, I've not really dealt with Clojure much.
Okay, cool. Yeah, I haven't either. I'm just learning. But this is pretty cool. So basically what this site does, it allows you to code to fill in the blanks, and then it runs tests on them to see if you pass. So in this case, there are two statements that are being evaluated here. This inner one is that one there, and then this outer one is just saying, are these equal? So if we put like Bob, then it should evaluate false. When it runs, yeah, you failed the tests because Bob does not equal the result of this statement here.
Oh, I see.
So it's a 2 uppercase for hello world. So I'm going to go out on a limb and say this is going to be the solution. Yep, there it is. And then I think you should be able to go to the next one. Turtle lists. Does anyone want to take a shot at this one? So I will tell you that this is the syntax for a list in Clojure. That's one of the syntaxes. This is another one of the syntaxes for a list. So you can put this single quote, which is kind of a shorthand for a list, or you can make the first element of the list this list function name, and either way you will be creating a list.
Okay, so the idea here is to make a list that equals ABC?
Correct.
Oh, okay. Is this a interactive screen share, or do I just jump right in and click around?
I mean, I can type it in if you want.
Okay. Because I wouldn't even know where to start, so I guess it would be just a, what do you call it, the single quote and then the ABC within parentheses that creates the list.
Okay, so like
There. Okay, ABC.
let's give it a shot. No.
Oh, great, I failed. Okay. So I'm trying to understand the syntax here. So it's an equals list. Do we want to equal a list that equals?
Let's go out before we go over there. Let's go play around in the REPL here real quick, just to give you an idea what's going on.
Yeah.
Okay, so the main thing with Clojure is it's list based. So the basic syntax for a list is going to be if you don't need commas between the values. So this is a list that is 1, 2, 3, 4.
Got it.
Or you could make a list that's a if you don't include this little quote thingy at the beginning, it's going to evaluate it as code. So, for instance, if you put that, it's going to perform the addition function on 1 and 1. So you get 2.
I see.
Or like if you have count, that, oh, it throws an error. I don't know why. Because I didn't pass it a list, I passed it 4 values.
Got it. Yeah,
So we pass a list of 4 elements to count, and we get 4.
yeah, so the other syntax with the parenthesis equals is doing like an assert equals, I gather?
Exactly, yes. This is saying
Got it.
this
Okay.
outer one is like, are these equal? And then it's going to evaluate to true or false. Exactly. And here, let me just... so we saw one way to make a list, and that's with 1, 2, 3, 4. There are other ways to make a list, like this. And that makes a list as well. And I think there's another way, but I can't think of it at the moment. There's probably another way. So like for this one, the solution here, you're filling in the blank here, which these values are getting plugged into
Got
the
it.
blank.
Okay.
So,
That's
so
what I
we're
need.
making the
Okay.
list the same as this. Here.
Got it. Yep.
Yeah. Cool. Let's move on to the next one here. Okay, so when operating on the list, the conj function will return a new list with 1 or more items added to the front. Note that there are 2 test cases, but you're expected to supply only one answer, which will cause all the tests to pass. So this is like an append to the beginning of the list, a push, I guess, in another language. So once we can conj, I don't know if that's pronounced correctly. I'm just guessing here. Is it short maybe for conjoin, or?
Probably. That would make sense.
Yeah, so it's like a list concatenation. So we want to say something. What do we put in the underscore to make a concatenation of? Oh, if you do a conj of the one list to. Oh, I get it. I know this. So the top one would be 1, 2, 3, 4.
Okay.
A list of 1, 2, 3, 4.
A list of 1, 2, 3, 4. Let's try that.
Yes.
They should be the same solution. So let's give it a shot. There you go. You got it.
Got it.
Which also shows that with the second one, it's going to add them on one at a time.
Yes, it's going to take the first one, or no, yeah, it's going to take that one and add it on, and then it's going to take that one and add it on.
Yeah.
Yeah, I see it. And it evaluates from left to right.
Yep.
Interesting. Okay.
All right, so let's try another one. Intro to vectors. Vectors can be constructed in several ways. You can compare them with lists. Note the square brackets surrounding the blanks are part of the test case. Okay, so I guess if you send multiple values to equals, it's going to check them all for equivalence, because we've got a statement here.
Got it.
We've got a statement here. We've got a statement here, and then we have the one that we need to make. So here, let's go over to the REPL real quick. So if we say vector A, B, C, we end up with that. If we say vec, that's A, B, C, end up with that.
Okay, so what's the difference between a vector and a list? Just a different data type?
It is. They're both. From what I know, they're both collections. The vector is made to be indexed into, whereas a list is more of a pure functional collection.
Got it.
So I'm going to go out and I'm going to say, because we got square brackets around the answer ABC here, that is probably going to be what goes in the square brackets over here.
Yeah.
Yep. Cool. Out of curiosity, I wonder if we rearrange them if it's the same.
I'm guessing no.
Really is not.
So these are like code katas here. This is kind of interesting. I'm doing something similar online with what do you call it, Kotlin lang. I'm learning Kotlin the same way. They have a whole interactive thing just like this, which is kind of cool.
What language is it?
Kotlin.
Kotlin. I'm not familiar with that.
Yeah, that's something new by JetBrains, the makers of Android Studio and IDEA. It's my favorite tool, my favorite company, because they make my favorite tool, IntelliJ IDEA. It's like the best IDE on the planet. It's Kotlin with a K? Yeah.
Oh, Kotlin with a K?
Yeah, you sort of complete for you. Yep. You can go to kotlinlang.org and they have something very similar. And that's supposed to be the new, like, JVM cool language that lets you do, like, it compiles down to JavaScript and it has really tight Java integration. It's supposed to be, you know, a better Java for Java programmers. Nice. And I'm actually in the middle of doing a comparison between this and Groovy, my other favorite thing to play around with.
So you're a JVM programmer?
Yes.
Okay.
Originally
so
born in
JVM as well.
I'm sorry?
Clojure's right up your alley. It's on the JVM
Oh,
as
yeah.
well.
Right, absolutely.
Okay, so try online. Let's take a look at Kotlin real quick. I've never heard of it, so.
Yeah. I'm actually considering using this at my job. You know, we're doing a new Android app pretty soon, and I'm wondering if I should stay with Java or if I should graduate.
This is interesting. So this is kind of like Groovy or like Swift does for Objective-C. It's taking some of the verbosity out of Java and making it more approachable. At least it seems like it. Is that a good assessment, or would you describe it differently? How would you describe Kotlin? Oh, did it lose you? No, you're still there. Ah, it's the tunnel.
Why do you do that to us?
I can't see if people are muted or anything without going to the tunnel. This is interesting. It's like Java if Java didn't have so many words. Look real quick. Kotlin Groovy. Okay. So it's a statically typed still. That's cool. That's interesting. I'll have to check that out. Oh, Clifton dropped off. Hopefully rejoins. Okay, so let's try this. Yeah.
Mm-hmm.
I did this one too.
Oh, I guess I dropped.
Oh, there you are. You're back.
Yeah. I guess the call dropped on me.
So, yeah, it looks cool. I like it. It's a lot less words than Java,
Yes.
which is good. I'm not sure I understand this.
So let's go back over to Clojure, though. I'm kind of interested in what the next thing on Clojure was.
Yeah, sure. Conjoin with vectors. So I think with lists we saw that it goes to the beginning, but it says when operating with a vector, the conjoin function or conj function will return a new vector with one or more items added to the end. So I assume that conjoin is going to return a vector for us. And it's going to have 1, 2, and 3, right?
Mm-hmm.
And then it's going to take the 4 and put it on the end.
So let's try
Yeah.
that. Yep. There we go.
I gotta say, I don't like the fact that for lists, it appends it to the beginning, and for vectors, it appends it to the end.
I think that is a little confusing. I assume there's a reason for it, but I don't know.
Yeah. I'm hoping so.
Oh, yeah, I didn't catch that. So, yeah, vectors. Okay, so the list it appends to the end. The vectors go to the beginning.
Yeah, here, let's try this out in the REPL real quick. So,
No, Clifton, the other way around.
Oh, I see. Yep.
Okay, so if we have conj, I gotta say I like not having to type commas.
That is nice. Yes, I do like that.
Commas are easier to reach than parens.
True. Yeah, look at that. It goes to the end, and then it goes to the beginning. What I've seen so far is that these lists are more like a standard Lisp data structure, whereas these are more like your typical like Python or your modern language collections where you append the end. So that might be part of why it works differently, but that's just a guess.
That's what it seems like.
Yeah, I would agree. Okay, sets. Intro to sets. Sets are collections of unique values. Let's play with the set here real quick. So if we have didn't like that.
I think you need to pass it a list.
You are correct. Sets are squiggly braces with hashtags in front. So we pass a set, a list that has duplicated items. That's handy. It gets rid of duplicates for us. Okay. Clojure set and union. Let's see what that does.
There's something in Python that does that thing similar to what set does, right? I think.
I think there is a set data type.
Yeah.
Or
Yeah. Oh yeah, it's called set.
Doing a combination is combining the two sets into one.
I
Is
think
that what
you're
that's
right.
doing?
I think you're right. So if it is, we should get 1, 2, 3, 4, 5. That's exactly what we got. Okay, so I think what our result's going to be is it's going to be ABCD, right?
Yeah.
Yeah.
So there we go. Awesome. Make sure the sets. Oh, we got cons with sets. Oh, whoa. When operating on a set, the cons function returns a new set with one or more keys added. So I assume this is going to be a 2.
That seems to be the only thing that would make sense.
So does the order not matter when you're using sets?
I would guess that the order does not matter. That's consistent with the Python sets.
Order doesn't matter when for equivalence with sets.
Right. A set is order agnostic.
Yes.
It's just a collection of values, unique values. So it makes sense.
Absolutely. Oh, maps. Okay, maps are key value pairs, or store key value pairs. Both maps and keywords can be used as lookup functions. Commas can be used to make maps more readable, but they're not required. I think we need a REPL. So A10.
I don't think you want the curly brace.
No.
Or do you? Oh, never mind.
I don't know. I was just trying to make one.
Oh, he dropped again.
Uh-oh. Okay, so that's how you make one. Now if we evaluate it, let me see, get 20.
What happens if you evaluate it in the other order and put the B first?
You get 20.
Okay.
Oh, are you back? Okay, so that's interesting. It doesn't matter. Try this.
Is there values?
Vowels. There you go. Clojure's interesting because it's familiar but different. It's almost like some kind of secret code for writing programming.
Well, I think the familiar parts are pieces of it that have been stolen and added to other languages.
I think that makes sense because isn't Lisp like one of the original programming languages?
Yeah.
One of the
And it
original
wasn't.
functional languages.
What's that?
It's one of the original functional languages.
Yeah.
It was an outgrowth of an academic paper where the author basically stated you need these couple of things for a language to be complete and for you to be able to program anything you want to in it. And then someone actually built something off of his theoretical academic paper, and that was the original Lisp.
That's crazy that it survived so long. Okay, so we create a map here, and then we're looking for the value of b, right? Which is going to be 20, and I think it's doing the same thing here. So 20 is going to be cool. And now we have conjoin or conj for maps. When operating on a map, the conj function returns a new map with one or more key value pairs added. Looks like we represent a key value pair with a vector.
Can you do the same thing with a list? Can you do like a list of in the middle there? Like, could you put in B2?
Let's try it. List. Keyword cannot be cast to a map. It doesn't look like you can do it with the list.
Hmm. You got the limiter wrong, bracket wrong.
Yeah. Okay, but you can do it with a vector.
Okay.
Now, I think you can convert a list to a vector by just wrapping it in square braces. No.
I think you can add the you could add the vector keyword.
Oh, no, correct.
and you need a quote in front of that
Yeah,
list, the
for the-
C3 list.
That's a vector of lists. That's
It's a
slightly.
vector of list. So you would need this. So if you had a list, you wanted to convert it to a vector, could you conj keyword vector onto it? And then evaluate it? No, you can't. A persistent list cannot be cast to a Clojure function. Okay. So that's not how you do it. I don't know. I was thinking that maybe you
right
could.
there. That's creating a some type of vector object within a
Yeah.
list.
It's creating
Or
a
I don't
vector.
understand what that's.
I think it's actually creating the vector because you can see the values here. You can see that the class
Right.
name is a vector. It's just printing out incorrectly because it's not evaluating it. Or
Is it putting a vector inside the list? Is that what it's doing? Like
one
an
of the things about
vector inside the list?
No, it's putting the list inside the vector.
Are you sure? Because it looks like a list with a vector reference is the first C element and then the 3, all inside of a list with the parens.
yeah, I don't know.
Yeah, because you're conjoining the vector to the list. If you reverse the arguments, if you did conj vector and then did the list, would that do something different?
I don't know. We'll try it out. Oh, it doesn't like that.
Yeah.
Oh, because then it's trying to put that pair. I don't know. I'm confusing myself.
Does conj only work with lists, or what does conj operate on? Is it operate on a list or on a vector?
It will
Both.
operate on either one.
Okay.
And a set, and a map.
Yep. Okay. So we've got A1 in this already. We've got C3 already. So I'm guessing we need to add B2.
Yes.
B2. Yes. Cool. What do we have next? Intro to sequences. Ooh, first, second, and last. Let's see what those do. Nothing. The wrong number of our. Oh, I need to pass it a list. I didn't pass it a list. The first element, I suppose, of the list.
First element.
Yeah.
Element of the list.
So the answer to that problem would be 3 in all cases, of course.
Yep.
I would agree. Let's give it a shot.
I must say, I'm surprised that there's a second operator.
Yeah, I wouldn't expect that either.
Yeah. Is there a third?
I don't know. Let's
That
see.
is interesting. Nope.
What happens if you do second on a list that's only one?
I guess there's no third operator.
No, there's no third. Okay. So intro to sequences. Sequences rest. The rest function will return all items of the sequence except the first. Okay. So rest here, I assume, will give us 20, 30, and 40.
It would
sounds
be really
right.
interesting if they implemented the fourth operator and just decided to skip third.
Let's see.
I don't think that's the case.
I don't either. Oh, there is no fourth. Intro to functions. Clojure has many different ways to create functions. Okay, so what do we got here? An add5 function. So I have gone through the beginning chapter of Living Clojure. If what I remember, this creates an anonymous, apparently not so anonymous function because we have a name right here.
I have to get close to my router before I drop.
Uh-oh. Hopefully you don't. Here's our parameter. So parameter is going to be a single parameter. And then it adds 5 to it. Just to separate out the parens here. Oops. This is our function definition here.
Oh, and that's what the argument they're passing into the function.
And they're passing 3 into the function. So that should be 8, because we're adding 5 to 3, 8.
Yep.
And it looks like they rewrote it here. They didn't give it a name this time. And otherwise, it's pretty much the same function.
Agreed.
Yeah, go ahead.
No, with the anonymous functions, they named it there, but I think if you had that in a program, you just couldn't call add5 a bunch of times. Isn't it like a lambda? It only works once?
I believe so, but I'm not sure.
I think you're right because there's a different notation for functions that you want to actually save for a while.
Okay. Yeah, it doesn't know what it is.
Oh, okay.
I think what this does is it allows you to do recursion. So you can call it something in here and then call itself, because it's still going to have a name inside of the function definition.
Okay.
I think you're right.
I see what's going on. So if you wrap that function call with parentheses, it evaluates the function. That's the actual calling of the function. Put an extra. That's what I wasn't. Okay.
Correct. Okay, so I don't quite. I guess this putting a hashtag in front of a list makes a function, an anonymous function. Percent is your parameter, and so this should come out with true because 5 is greater than 3.
Oh, I think I've seen that before, that kind of notation. They used it to check if there were capital letters in a string of words, but they used the capitalization thing in Java inside Clojure, and they used that pound symbol and then the little modulo there, the percent.
That seems like it might be handy for some really quick shorthand, but it could get really confusing real fast.
Yeah, you're moving into Perl territory there.
Yeah, regex. Yeah, exactly.
So that modulo is shorthand for what? Is that just to declare the? I don't understand what that is.
I think it's like string interpolation, where that's just the position that the parameter gets passed into.
Ah, got it. Got it.
Okay, and parcel, the parcel keyword, I don't necessarily understand that keyword.
Partial takes a function and it applies the variable you give it to one of the parameters of the function and returns you a function.
It's like a curry then.
Not familiar with curry.
That's pretty much the definition of currying. So when you do a curry in other languages, like first time I've seen that was in Groovy. I think Ruby does Ruby do it? Somebody Python. One of them has curry. It basically takes the lambda or function and inserts your parameter, like fills out the first parameter in that function argument list with a fixed value and returns a function that you can call a curry.
Yeah, Python calls it partial as well.
Oh, okay.
Okay.
Yeah, it's called currying in like Ruby and Groovy.
Currying means that we rewrite the function as a composition of 3 functions, a function for each parameter. I'm not sure I understand.
It's pretty much exactly what we just described on the Clojure example. It just takes a function and a parameter and uses that parameter as a fixed value of the first parameter of the function that you give it, and returns a function basically.
Okay.
Yeah, okay. It's partial basically. It does the same thing that partial is doing.
Okay. So this is the function. It's
the function is +5, and you are returning +5, prefixing or filling in 3 as the first parameter, as a constant parameter, and it returns a function that you can call, and then the outer parentheses are actually invoking that function.
No, it's taking the function plus, which takes 2 parameters.
Oh, got it. Yep.
It's putting the 5 into the first parameter, and returning the function.
It's almost like a Clojure, not the language, but the.
Yeah, it is.
It is. That's exactly what it is. Yep.
Okay, I get it.
So the plus is the function in this example. The first parameter is the actual function that's being partialized or curried.
Okay.
And then the second parameter is, you give it a function. Okay, I get it. Yeah, you give it a function, you give it a parameter. Okay, I get it now. Yep.
Okay, that's pretty nifty. Okay, so in all cases we're adding 5 to 3, so we're going to get 8. Double down. Uh-oh. Write a function which doubles a number. All right, so help me out here.
It would be times 2, so you could do a well, I forget the syntax now. It would be I guess you could do the shorthand. I don't want to do shorthand. Let's try the partial. That's the only thing I can remember now.
All right.
Partial, and it'd be an asterisk and 2. And close paren, and try that.
Okay, let's give it a shot.
There you
go. Nice. Okay. Let's try one of the other syntaxes.
Yeah.
That's
the
sweet.
way I would have done it would be the open paren, fn,
okay,
space, bracket x bracket, open paren, times x2, close paren, close paren.
Okay, so that's making an anonymous function that accepts a parameter, and then passing that parameter into to multiply by 2.
Yeah.
Sweet. I'm going to round it out, and I'm going to try.
Is that the pound sign I'm seeing?
Yeah, that's the pound sign. So that's passing It's going to pass the parameter in there and multiply 7 by 2, or 11 by 2, whatever the parameter is by 2, I think. Sweet.
Nice.
Jonathan, do you have another solution for us?
No, I think we did it. I think we did it all the ways, except for
We need to
naming the
name one.
enormous functions. Huh?
We need to do a name function.
All right, yeah, give us the name one, Jonathan.
Okay, so we could do. Let's see. Open the open paren defn.
Okay.
We could name it times 2. Doesn't, you know.
Okay.
The bracket.
Mhm.
X. Let's see. Open paren star. Oh, well, close bracket after the X. Close bracket, open parenthesis, star.
Okay.
Space X, space 2. Close parenthesis, close parenthesis.
All right, let's give that a shot. Sweet, we did it 4 different ways.
Yeah.
We quadruple downed. Hey, it's a little unfair that we've done, what, like 12 of these, and we just got to Hello World.
Yeah, that just seems wrong.
Yeah.
Okay. So let's create a function. You're gonna pass it a name, and it's gonna say hello, comma, space, name, exclamation point. I did this. I did this one before. I will tell you that there is a function str which will combine strings. If you
Okay,
say
that's a conj.
to space bar, this str concatenates them together. I don't know. We could try conj. Does that work?
Let's see. Nope.
No. Maybe if one of them was already a list. Oh, okay. So it.
It says a list of foo and bar.
Yeah. Okay, so str will combine strings. Who wants to give this function a shot?
Okay, I'll give it a stab. So let's try, what is it? Fn space bracket X, close bracket, and paren str space hello, literal hello with a comma and a space, and a close quote, and X, and a close paren, and another close paren.
All right, let's give it a shot.
What did I do?
The exclamation point is missing.
Oh, there we go. There's the little thing.
Yes, good one. Yep. There it is.
Nice. Good job.
Tag teamed it.
That's right. Oh, look, regular expressions are coming up. Map. The map function takes 2 arguments, a function f and a sequence s. Maps returns a new sequence consisting of the results of applying f to each of s. So it's not the data structure. Oh, this is like mapped in Ruby or Python, where
Yeah.
it applies a function across all elements of a list. So if you said map +1, that's essentially what it's doing here. It's adding 5. So this function here adds 5.
Yep. I agree.
Each element of that list. And we're going to end up with a list that is 6, 7, and 8. That makes sense?
Mm-hmm.
Yep.
Nice.
The filter function takes 2 arguments, a predicate function, and a sequence. Filter returns a new sequence consisting of all the items for S, of which F item returns true. Okay, so there's a filter in Python. Or it's like the if clause of list comprehension. I think Ruby has a filter as well. So basically, it's going to remove any items from a list where the function returns false. So if we did filter so this should return a list that only has 1 in it, because we're saying filter out anything that doesn't equal 1 out of this list.
Agreed.
Or if we said greater than 1, then it should give us 2, 3, 4.
Mm-hmm.
This is greater than 5. So 6, 7.
Nice.
Clojure lets you give local names to values giving or using the special value let form. Okay, so let and then a vector and I don't know what that's called. A code block?
A list.
A list. Yes, a list.
Right.
Okay. So it looks like these pairs are key value pairs. So this is saying let x equal 5 and evaluate this list.
Agreed.
Or let x equal 3 and 10 and evaluate that list. Okay. So if x equals 5 and we add 2 to 5, we get 7. If x equals 3 and y equals 10 and we subtract 3 from 10, we get 7. If x equals 21 and y equals 3 and we divide, I assume it's 21 by 3,
Yeah.
then it's 7. Although, that's not super intuitive. Or is it?
Well, it's standard syntax. You do x divided by y. So the fact that here we're doing that the operation is divide, and then we do x, y, says to me that it should be x over y.
Okay, yeah, that makes sense. because we're moving the operator from the middle to the front. Okay, that does make sense.
Mm-hmm.
All right, so we got 7. All right, we'll try one more. Can you bind X, Y, and Z so that all these are true? Because this is going to be a... So when X and Y are added together, we get 10. When Y and Z are added together, we get 4. And
Z is 1.
Z is 1. Yeah, I agree.
So then it's 3. Y is 3, which means X must be 7.
Okay, let's give that a shot. X is 7. X is 7, Y is 3, and Z is 1. There you go. Nice.
Nice.
I was actually nervous about that one.
No, that was good. You just put that right together.
I've been arithmetic challenged lately. I was trying to help my daughter with her homework the other day, and I got her all kinds of confused.
Oh, no.
Yeah. You know how you overcomplexify something? You know, it's supposed to be a 6th grade math problem.
Yep.
Yeah, I've done that.
I actually wrote the teacher a letter. I want to speak to the teacher because I think that the problem was actually too simple. The way that they solved it in class, I'm not happy with it. The way it was worded, it was worded to be a lot more complicated than the solution that was given as the accepted answer. So I have a problem with that.
Yeah. I can see that.
One of my many personality flaws there. I get obsessed over things that are slightly off.
Well, maybe you can improve the curriculum.
Yeah, exactly.
And
I hate to be the parent that goes in and tries to take over. I'm teaching class. I'm not that parent, but it's just when you know something that's slightly off, a flaw that I don't want my daughter to be confused. That's the thing. It's like they gave an answer in class that did not match the problem, so now I have to go in there and discuss it with the teacher because I'm not happy with that solution.
Yeah, that makes sense. I'd do that too. Okay, so regular expressions. I think I'm going to have to bust out a REPL here. So I think intuitively I understand what this is doing, but the syntax I don't understand. My guess is it's looking for uppercase letters.
Yeah, so we're taking string, which does the concatenation of all of its arguments, I suppose, or no, apply string RE sequence. Okay, so yeah, let's just try it in a REPL.
Yeah, let's just take this part and see what we get.
Mm-hmm.
Oh, whoops. This part. Oh, and I need to get rid of my extra. This plus. It gives us a list of the uppercase letters because we're looking regular expression. We're looking for any uppercase letters.
Okay.
And with that plus, does that give us? Okay, so it's looking for a series of uppercase letters. It'll pick up those because of the plus. So that's kind of like a regular expression.
Yeah.
What is this apply string? Oh, that's what we were trying to do earlier, where we were trying to make the
string into a list into a string or conjoin or something. Yeah.
Yeah, we were trying to apply vector to a list. Yeah.
Nice.
Okay.
So apply string to. So basically, it's append or prepending this value to a list, and then it executes that statement, that block, that list.
Yeah.
Okay. Okay, so this is going to pick out A, B, and C, and then it's going to put them together and make C. That is actually really succinct code for what it's doing.
Yeah.
That's kind of powerful. I like that.
I like that too. I mean,
I'm trying to imagine what it would take to write something comparable in Python.
It would be at least a few lines.
Yeah, it would.
I'm thinking I could get something close to that in Groovy.
Yeah.
Yeah, I think I could probably hack that.
I like that apply.
Mm-hmm.
So if we have a list that if we have a list that is give that list, and we say apply plus that list.
So it's everything. It gives everything. That's kind of like a spread almost. Spread operator.
Mm-hmm.
Applies all the values in the list as parameters to the function. I like that. That's really nice.
That's nifty. All right, what do we have? Intro to reduce. Oh, I think I just did this. But apply. Reduce does something similar.
Haven't we already used reduce?
I was playing with it earlier when I was trying to do that max.
Oh, that's right. That was before we started working on this. Got it.
Yeah. So reduce in Python, it would do. Do I still have that?
Yeah, it's right there.
Yeah, here it is. So basically, you establish a value outside of the scope of your loop, and then you go through your loop and apply some function. In this case, we're looking for the max value. So if the current value is greater than the max value, then the max value is the current value, and then it returns that value. So in this case, if we said instead, if we said use greater than,
I think you're going to error out.
I might. Okay.
It'll apply the greater than sign to the first two numbers, and I don't know which direction it goes from.
Yeah, it's because it's getting a true as a result of a greater than rather than a number.
Yeah, and then it's trying to compare true with a number, and it's going, I don't know what's going on.
Okay, that makes sense. Uh-oh. Recursion. What's going on here? A recursive function is a function which calls itself. This is one of the fundamental techniques used in functional programming. Excuse me. Anyone want to take a stab at figuring out what this thing's doing?
So we are, what is it? Decrease dec, is that a decrease decrement x?
I believe it's decrement.
I believe so too.
So Yep. Decrement. Okay. So we decrement x. So we're given 5 as our parameter.
Mm-hmm.
Oh, see, this is where it gets confusing because all these parameters, I mean, these parentheses, this is where it's all listed. So we take
So
5 and we put it into that inner function, which is decreasing it, and turning it into a 4. And we pass that to foo, which takes and compares the x, which is 4, and as long as it's greater than 0, it will conjoin it. So we're just doing a countdown from 5. It's going to do like a 4, 3, 2, 1.
let's see.
Uh,
No, it's going to take that. The 5's going to be added on from the x at the end there.
okay.
Is it at the beginning or the end?
Beginning.
Nice.
Hmm.
That was impressive.
I missed that one. Okay, so 5 is, wait a minute, the 5 is, how's that working?
All right, let's start with
So I think the 5 is being passed in here and not there.
Right.
So
Right.
if we start by thinking about this with 1, no, with 0, it's not doing anything because that doesn't satisfy the when clause.
Mm-hmm.
So then we pass in 1, and we're going to return the conjunction of the empty list from foo of 0 with 1.
Why do we start at 0?
He's using that
Because I know that's where the recursion's going to end.
Okay.
Because of the when clause.
Okay. No, I was just curious because I mean I would have started with 5, but then
I think it's messier if you start it with 5.
Okay.
He's doing almost like a dynamic programming type exercise. He's unwinding from the end of the his terminating case. He knows 0 is going to terminate, so then you go to 1 and you figure out.
That makes sense because none of these functions can evaluate until that 0 evaluates.
Right.
And so we're actually counting from 0 up to 5. Whoa, that was kind of mind-bending.
And that's why you're supposed to learn a Lisp.
Okay. So we started here at 0, but 0 doesn't...
0 doesn't return anything, so it's just going to be the empty list.
And that just ends the function because we no longer are doing recursion at 0.
Right.
Why don't you copy that function definition over into the REPL, and we can play with it.
Okay.
But change it to the, what is it? Defin?
The named version?
Yeah. So now, foo of 0.
Mm-hmm.
And then from there we can do foo of 1, which is going to be conjoining 1 to the end of the result we got from foo of 0. And so now foo of 2 is going to take 2 and conjoin it to what we just had.
Okay.
And then foo of 3 will take 3 and add it to what we just had, etc., etc., etc.
We said foo of 10. Oh. And that's all just one function.
Mm-hmm. With nothing being modified.
And I can see how you can do a really quick and terse Fibonacci
Yeah.
Except here.
Yeah, totally.
It's kind of cool. Well, I get it in there.
So if you did... I don't want to get into Fibonacci right now unless you guys want to.
No, that's all right.
Rearranging code. I'll call it an arrow. I don't know what that is. Dash greater than?
Arrow sounds like a good name for it.
Okay. The arrow macro threads an expression x through a variable number of forms. First, x is inserted as the second item in the first form, making a list of it if it is not a list already. Then the first form is inserted as a second item in the second form, making a list of that form if necessary. This process continues for all the forms. Using arrow can sometimes make your code more readable. Okay, maybe this code will make more sense. Okay, so it looks like there are three...
Hey guys, I'm going to drop off.
All right, thanks for joining us. Have a good night. Okay, so this looks like we have three different statements here that are equivalent.
Okay, so here's how I read the description of that arrow. So if we look at that second line, the arrow...
Sorry, go ahead.
Yeah, the second line, the one that starts with the arrow. It's saying we're going to take that vector and we're going to add it as the second argument in that first list with reverse.
Mm-hmm.
So we'll apply reverse to that vector.
Mm-hmm.
Then from there, we're going to take the result of that and add it to the end of the rest list. So we're going to apply rest to that.
Yep.
Whatever that does.
And then sort, and then the blank.
Yep.
So it's like it's turning this inside out.
Yes. Okay. The point is that they think that the second line is more readable than the first line.
Yes.
Which it may very well be because of that string of parens at the end.
Yeah, it's getting rid of some of the nesting.
Yeah.
Actually, that's exactly what it's doing. It's getting rid of the nesting. It's just representing it, and it's saying apply these in this order.
Yeah.
Okay.
All right. Does anyone know what the rest function does?
Yes, rest gives you everything but the first item of a list.
That's right.
So if we reverse this, then we start with 6 and go that way. And we do rest. That would be 3, 1, 4, 5, 2.
Then we're going to sort.
Then we're going to sort it. So we get 1, 2, 3, 4, 5.
Or 5, 4, 3, 2, 1.
Or 5, 4, 3, 2, 1. And then we need another function to give us just 5. So I'm thinking that's either going to be first or max. Or maybe both.
I was thinking first or last.
Okay, let's try.
But you're right, max might work. Max probably will work. No.
Last works. No. 5 items. Count works. Min? No, that wouldn't work. First. Max doesn't work. I would think max would work. We reverse the list. So 6 is the first item, and then it gets chopped off.
Can you not apply max to a vector?
It's possible. I bet they weren't expecting count. That lasts.
Yeah, max doesn't apply to a vector. Actually, it does. It returns the vector. Which makes
the
me
whole
wonder
thing?
what happens if you apply it to two vectors. Oh, it errors out.
Sure does. Vector cannot be passed to a number.
What's the point of maxing the vector then?
No
I
idea.
have no idea. I did not expect that to work. I would be willing to bet that there's some sort of logic in there of if you're only passing in one thing, just return it, and it doesn't even bother to type check it to see if it makes sense.
But that might be, huh? Yeah.
What happens if you put another string in there?
It says it's not a number. So yeah, I think you're right. Max with one parameter always returns whatever is passed to it.
Yeah.
Do you guys want to keep going, or are you good for tonight? Or do you want to see what the next one is?
Let's see what the next one is.
Clojure only has one non-stack consuming root construct, recur. So it's tail recursion or tail optimization. Either a function or a loop can be used as a recursion point. Either way, recur rebinds the bindings of the recursion point to the values it is passed. Recur must be called from the tail position. Calling it elsewhere will result in an error. All right, I think this is a good one to challenge, and then we'll call it a night after this one. So, what the heck is going on? We set up a loop.
And their loop is very straightforward. This loop.
That's right. We have we're declaring x equal to 5, and we set up a result vector.
Yeah, that's what it looks like.
If x is greater than 0, recur passing x minus 1 and the result of adding 2 to x conjoined to our list. Okay, so we're creating a list, or a vector, sorry. We're creating a vector starting at 5, then 4, 3, 2, 1. So let's start that starting at 0, because that's our end case, right? And we are generating this. 0 is not going to give it on there, so we go to 1. When x is 1, it's going to be 3 because we're adding 2. When x is 2, it's going to be 4. X is 3, it's going to be 5. X is 4, it's going to be 6. X is 5, it's going to be 7.
I think you're right. Although there could be an off by 1 error in there somewhere.
All right, let's go to shot, see what it says. Yes!
Awesome.
Sweet. We're almost all the way through the elementary stuff. That was
Yeah.
that was some good work. Clojure's interesting.
Definitely.
That was
Certainly
cool.
forces you to think about things in a different way.
It sure does.
Oh, wait. Oh, there it is. Fibonacci.
that was cool.
Yeah,
I'm
we're going to
definitely
have
gonna
to do
be.
this again.
Yeah, I agree.
Yeah.
Hop on here again this weekend sometime. I'll give a shout out to the Hangout first. All right. Well, let's stop this broadcast.